Hello learners, I'm Mr. Saul, and today we're going to keep talking about light and the ways it can behave. Now last week we talked about how light always moves in a straight line until it reflects or bounces off of something. And when it does that, it allows us to see it. Now the thing that it hits might be opaque, something like my thick blindfold here that doesn't let any light through, right? So that would be opaque. Or that thing that the light hits might be something that's translucent. It might only be letting some of the light through, like my sunglasses that darken things for me. Or if all of that light is able to come through and it doesn't block any, then that is transparent, like my safety goggles that block physical things from going through, but light can go through just fine. In today's lesson, we're going to take a closer look at just what is happening when light strikes these objects that are transparent, translucent, or opaque. First, let's take a look at reflection. When light reflects off of something, the light will bounce off of it and change direction. This happens all the time to everything around us. In fact, the only way we can see something that is not a source of light, something that is not creating its own light, is if light reflects off of it. The very best example of reflection is a mirror, something that we all use, well, most of us should use every day. Now a mirror is a very smooth and shiny surface, so when light hits it, it can bounce off and stay in very nice, neat, straight lines that are very organized, which allows us to see a clear image of that reflection. Next, I'm going to do a little experiment, and I want you to see if you can tell me what's going on using that word reflection. Welcome back. I hope that you learned something interesting from looking at that little experiment and that you were able to describe what's going on using reflections. Now it's important that we remember that reflections allow us to see everything that is not a source of light. So even if it's not something that's a mirror that's very shiny, it's still reflecting light back into our eyes. The light will always be bouncing off of things, doesn't matter if they're translucent, transparent, opaque. The light will bounce off and give us a little reflection. So even if I can see through water, I can still see the reflection on the top. That's because a little bit of the light is bouncing off the surface and shining up back into my eyes. Next up, I'm going to play a little video for you guys, and I want you to see if you can describe for me what's happening in this video not using only the words, but using these 4 words: transparent, translucent, opaque, and reflection. All right, here's the video. That's pretty silly. But why were those kids running into the glass? Because the glass was so clean, it was completely transparent. There was little or no reflection coming off of the glass, so they couldn't see where it was, so they kept running into it. So that tells us that reflections are very, very important, especially if we want to see the things around us and stay safe. Let's take a moment to think about how you use reflections, not in a mirror, but other reflections, any activity that you might do, anything that you might be looking at. What's something that you use a reflection for? I'll share one before we start. I use reflections to help me read my comic books. All right, Now you take a moment and see if you can think of something that you use reflections for. Welcome back. Did anyone talk about the moon? The moon is a great example of something that uses reflections. If it wasn't for the light reflecting off of the sun, we wouldn't be able to see the moon. Just like how sometimes we can't see the moon when it's closer to the sun than we are because we're only looking at the side of it that's in shadow, the part that doesn't have any light hitting it because it's being blocked. So, we know that light reflects off an object and it bounces and changes direction. You know what else changes direction? A bouncing ball. A bouncing ball is a great example of a type of reflection. When it goes down, it'll come back up and in a new direction. That is just like what light does off of everything. So, looking back, all three types of objects, translucent, transparent, and opaque, give off some amount of reflection if we can see them. If we can't see them, that means they're not giving off a reflection, and we saw what can happen if something doesn't give off a reflection. Now let's talk about refraction. Refraction is when light travels through something that is thicker than air, something like glass or water, and as it's going through, it has to slow down because it's so much more difficult to travel through something that's thicker like that. As it does that, the light is going to bend, and it's going to slow it down. As it does that, it can make things look a little funny for us. Like in this glass of water that I had out with a straw in it that now I can't drink out of anymore. Thanks a lot, Doodle. But you can see that the straw does not look right because the light is bending as it passes through the water, making the top of the straw and the bottom of the straw look like they're in different places. Refraction is also why we have rainbows. You see, white light from the sun is made up of all the different colors of the rainbow. But when that white light hits a raindrop that's still floating in the air, it will get refracted or bent. And when it gets bent, the different colors have a chance to separate. Red is the slowest color, so it's going to come out last and be on top of the rainbow. Purple is the fastest color, so it's going to come out first and be at the bottom of the rainbow. You can also see rainbows when you use your garden hose and set it to a mist setting and make sure that the sun is behind you so you can catch that refraction. The last thing I want to talk to you guys about today is absorption. Light is absorbed when light gets taken in and held by something. So if you're wearing a dark sweater and you go outside, you might notice that you start getting warm pretty quickly, and that even the fabric itself, if you touch it, is also warm. That's because light is made out of energy, and as that dark sweater that you're wearing takes in that energy, it's going to turn it into heat energy, and that heat will warm you up. So a dark sweater will get you warmer than a light sweater. Can you guys think of any other examples of where something that is darker gets warmer than something that is lighter? That's our lesson for today. I hope you guys learned a lot about light and the ways it behaves when it strikes different objects, whether it's being reflected, refracted, or absorbed. I'll see you guys next time when we take an even closer look at the ways light behaves. See you next time.